All right, so number 2 is,
That's Greensboro.
listen please, number 2 is 12 to the 1/2 power. Just multiply 2 times the 4th, right? That's a half. And number 4 is 7 to the 2/3 power. And number 6 is just 2/3. Number 8 is 5 to the 1/4 power. And 10 is 7 to the 5/4 power. Any of those you would like me to go over? We're all okay with all those? Jared?
6. Of course you have a question.
It's okay. What's the rule?
You don't know why I asked.
Yeah, I'm asking you, Morrison.
I have no idea.
Well, you should get an idea. Come on. What's the rule when there's one inside and outside? Add, subtract, multiply, or divide. Haley? Multiply, thank you. So what's 3 times negative 1/3? What's, same thing, right? 3 times negative 1/3? So you guys understand how we got there? What's the rule when you have negative exponents? Flip them. So the 6 goes up top, becomes positive 1. The 9 goes in the bottom, becomes positive 1 exponent. You don't have to write them, but it's okay. And then you should reduce that. What goes into 6 and 9? 3. So that's 2/3. Okay? Anything else? First 5. Now it's time to ask. If you're not sure, ask. It's okay. 10? Okay. Since these have the same base of 49, what's the rule with the 3/8 and 7/8? Add them, right? So what's 3/8 plus 7/8? 10/8. Well, what's 10/8 reduced to? 5/4. Divide both by 2, right? Okay? So I can change 49 to 7 squared. You guys okay with that? Is that all right? What's the rule? We just did it with one inside and one outside. Multiply. What's 2 times 5/4? 10/4. So now I have the same base. Since the bases are the same and it's division, what do I do with the exponents? Subtract them. So what's 10/4 minus 5/4? 5/4. And since the bigger exponent is up top, the 7 stays up top. Nothing left in the bottom. Make sense? And that was the answer to number 10. All right. Any others? The first 5.
I have a lot of questions.
Then ask them.
Okay.
So what question?
All right. Number 12 is 8. 14 is 4. 16 is 1/4. And 18 is 3.
Oh my God.
All right. 18 is the tough one. Let's go over that one. All right. And if there's any others, you can go over. So since these are the same radical, I'm just going to multiply. What's 3 times 18? 54? Is that right? Yeah, 54, right? What's 2 times 2? 4. All right, so that's what we have right now, right? So I should try to simplify these, all right? And 9 times 6, 3 times 2, 3 times 3. Can I simplify that, radical? I'm looking for how many? Is there 3 or something?
Yeah.
3 threes, right?
Yeah.
So what can I do with the 3? Outside. What's left? The 2, right? We turned the 6 and the 9 into these, right? So we're just looking at this last column here, all the 3s and 2s. So 3 3s comes out, 1 2 left, okay? This is just 2 times 2, right, like it was? Right, since it's index of 6, how do I get rid of that? Remember, there's no radicals allowed under here, right? So how do I get rid of that radical? I already have 2 2s, right? How many more 2s do I need? Well, I need 6 total, but I need how many more? 4, right? Whatever I do to the bottom, gotta do to the top, right? But remember, that wasn't under a 3, it's under a what? So don't get, I should have made sure I did that too. But that's a 6, right? Because that's what I did here. Okay? So this 2 is a little different than this 2. Because this is a cube root and this is a 6 root. Okay? You with me so far? Any questions? All right, so since I have 6 2s under a 6th root, what can I pull out? 2. The radical's gone now, right? And again, the reason I did that, we're not allowed to have radicals in the bottom. So the bottom is just 2. All right, so this is kind of weird looking because we got different indexes. I can't multiply them unless they were the same, like these were, like those were. If they're the same, I could multiply. So let's rewrite these with exponents. What's the exponent if it's cube root? Now 3, 1/3, yeah. So this blue one is 2 to the 1/3. What's this green one? 1/6. Remember that? Now why did I put 4? Because there's 4 2s. Okay. Now, what can I do with the 4 and the 1/6? Multiply, right? All right, so I'm looking at this. I'm going to move this top problem, because it's getting kind of messy and all scrunched together. I'm going to move it over here, just so you guys can see it better. So what I have here is a 2 to the 1/3 times 2 to the 4/6. Since these are the same base, what can I do with those exponents? Add them. Well, 1/3 is 2/6, right? You with me there? So what's 2/6 plus 4/6? 6/6. So what is 6/6? So that's just a what? A 2. You see how that happened? That's pretty tough, though. Okay? So we'll go back over here. What was already up there? 3. And what else did we get up there? A 2. No more radicals at all. Right, those will cancel. So that's how it got to be a 3. Now, how many of you just did it in your calculator?
I did in my head.
You're awesome. But you could do it in your calculator. What did I tell you yesterday? If it comes out to be a whole number, I'm okay with that, right? When am I not okay? When it comes out to a decimal, right? All right, so if you put it in your calculator and you got a 3, that's fine. Just put calc beside that you use to calculate. All right? But that is a tough one. But if you understand that, you can understand all of them. Is there a question of any part of that? No, I kind of made a mess of it because it's all over. You okay? Is that the helping? No.
Wouldn't it have been easier just to reduce the 2 to 4/6?
Oh, yeah. Yeah, here?
Yeah.
Yeah. Made it 3/3 instead? Yeah, 3/3 and 1/3. right? I mean, 2/3, 1/3, then you get 3/3 instead of 6/3. Same thing, right? Yeah, that's okay. All right, we good on those four? Any of the others? Okay. Those. Number 20 is 2 times the 5th root of 9. 22 is 4 times, the 4th root of 12 over 3. 24 is the 3rd root or cube root of 14 over 2. 26 is 6 times the 4th root of 5 over 5. Any of those? Okay. So, first thing I would do is to see if 25 goes into 1296. I know it doesn't. Oops, I didn't need that. I already know it doesn't because if I'm dividing by 25, what should the number end in? 5 or 0, right? So, but I just did it real quick. But I would try to reduce that if possible first, but it can't. Okay? So, I'm just going to do factor trees for both. One plus 2 is 3, plus 9 is 12, plus 6 is 18. Therefore, I know what number goes into that. 3 and 6 might, but 3 and 9. Since it's even, probably 6 also. I'm going to start with 9. And what is that? 1296. Oops. 144. Yeah. Okay. And then 3 times 3. 12 times 12. 3 times 4. 4 times 3. 2 times 2. All right, so I'm looking at why am I looking at just those numbers? Because they're what type of numbers? What's the factors of 2 and 3? 1 and 3, 1 and 2, right? They're called prime numbers. Okay? So, do I see 4 of anything? Yeah, I see 4 what? 2s and 3. So what's the 4th root of that? 6. Okay? So the top's just 6. You with me?
Yeah.
Okay. The bottom is this. What do I need? 2 more 5s. Why? Because we want a total of 4 of them, right? We understand why I need 4 of them. Remember, we're not allowed to have radicals where? On the bottom, denominators, right? So that's why I need 4 of them. Okay? So the bottom ends up being what? 4 5s, 4th root of 5 to the 4th is 5. Okay? And then it's just 6 times the 4th root of, what's 5 times 5? 25. Okay? Or Cindy Quinn. All right? Now, that's not what the book says. It says it's supposed to be a 5. What am I doing wrong? Did I mess something up? I don't think I did I?
I got it back.
Okay? I had to do whatever I did at the bottom, I had to do to the top, right?
My rest.
4 through to 25. Now that should be it, right? Quiet. All right. I know. Last two.
Oh my God.
28. -2 plus the square root of 5. And 30 is 99 plus 11 radical 6 in the numerator over 75 in the denominator. Do I need to do either one of those? Robbie, tell me what I'm supposed to do.
I don't know.
I'll do the problem.
You're supposed to know.
I know.
Oh, that's right. You skipped yesterday, didn't you?
Not even
No, that was the
skip
day
yesterday.
before.
That was Wednesday. Thank
Yeah.
you. And I didn't even skip.
Yes, you did.
No.
What do we call this? Conjugate. Thank you. Okay. What do I do with the 11? Distribute. Morrison, I told you to be quiet. Coil. What happens to the 9s? No. 81. What happens to the outside inside? They cancel, right? And what's something times itself? Square root of 6 squared. Let's put it that way. Square root of something squared. That's how I should have said it. 36, but itself, right? What is 81 minus 6? 75. That's where that came from. Okay? So, again, that's the quick shortcut on the conjugates with the radicals. Square the first term and just whatever's under there. It's always minus because it's a negative times a positive. Okay? All right. Today, we're going to do radical expressions with the same index in radicand. They're called like radicals. We talked about like terms many times, right? Am I allowed to add x plus y? No. Am I allowed to add x plus x?
Yeah.
Am I allowed to add x squared y plus xy squared? No. Right? You guys understand like terms, right?
Yeah.
No. So, the same thing is true about radicals and indexes. The index is the same, the radicand is the same. I can add to those two terms now because they're exactly the same. If they're not, just like terms, I can't add them. So, what's radic? 4th root of 10 plus 7 4th root of 10? 8 4th root of 10. What's in front of this? A 1. What's 1 plus 7? 8. The 4th root of 10 part has to be the same for both in order for me to be able to do that. Okay? They have to be like radicals. That means same index, same number underneath. All right, this means eight to the 1/5 means the 5th root of 8, right? Are those like radicals? Can I add the 2 and the 10? Yes. So what's the answer? 12. 5th root of 8. Make sense? No, Robbie. Can't. Can you keep up?
No.
No, your answer is yes, I can.
Right. Yeah.
That was pretty good, Jared.
I'm not going.
Can you go? Keep going.
Yeah, I need to.
Slow, folks.
You came over and said something. Okay, I'm good now. The person that was
All right. What about C? Can I subtract those? No. All right. So if you get to one like this and they're not the same, try to simplify. Can I simplify the 54?
Yes.
Can I do a factor tree? All right. I want to go 9 times 6. And then 3 times 3 and 3 times 2. So I just did my factor tree. It's cube root, so I'm looking for a group of 3. Do I have a group of 3 numbers? Yes. So since I have a group of 3 3s, what goes out in front? 1 3, right? So this problem is 3 times the cube root of 2 minus the cube root of 2. Now are they like radicals? Yes. So what's 3 cube root of 2 minus cube root of 2? Correct, because there's a 1 in front if there's no number there, right? Just like 3 minus 1, right? Jared?
So if so if they weren't the same root, would we treat it like an
We-
x squared minus x?
We couldn't do it if they weren't the same root. They have to both be the same index. Okay, so they both have to be cube roots or square roots or fourth roots or fifth roots. Okay, in order to do what we're doing. Okay? Anything else, question-wise? Are these making sense?
Yeah.
All right, so they're not the same right now, right? So let's try to simplify the 48. Ty, how would you start?
6 and 8.
Okay. 2 and 3, 2 and 4, 2 and 2. What am I looking for? A group of 4. Do I have that?
Yeah.
So what can I pull out front? 2. Is there any number left? 3, right? Are these like radicals now?
Yeah.
Yes. So what's 2 minus 1?
4.
Right here, 1. What's 2 minus 4?
You don't have to put the 1 in front if you don't want to. Morrison?
Never mind. See, I know what I'm doing now.
Good. Because you're keeping up. Michael, you with us?
No, he was asleep.
Maybe we're all.
All right. So, listen. What's the square root of something squared? Self. What's the 7th root of something to the 7th power? Self, right? What's the 4th root of something to the 4th power? Itself, right? You guys already knew that stuff. They're just going through that. All right? I'm not going to worry about absolute value answers. All right? We're just gonna realize if we've got the same exponent underneath an index, they just cancel each other. All right. So I'm looking for groups of what? Everyone understand why I'm looking for groups of 3? Okay. So I'm going to do 8 times 8. Again, does it matter how I start? No. So 2 times 4, 2 times 4, 2 times 2, 2 times 2. You see that one? And this one, right? So how many 2's get pulled out? 2. What do I do with the two twos? Multiply. Okay? So for the blue set of twos, a 2 comes out. For the red set of twos, a red 2 comes out. And you multiply them. Okay? For the Y's. Isn't that what y to the 6 means? Why did I put them in that way? Because I want them in groups of 3. That's why I did it. If it was 4 through, I'd put it group of 4. Does that make sense? So, I should have done a different color for each. But, for this group, what comes out? A Y. For this group, what comes out? A Y. Okay? So, what's our answer? I heard somebody say it. 4y squared. Make sense? Now, here's what you can do with the variables. What's that exponent? What's that index? What do you get when you divide them? 2. That's going to work.
I'm so confused.
And it's 4 because 64 is,
Yeah, it's a perfect cube, right? You could put the cube root of 64 in your calculator and you'll get 4, right? But I was just showing all the work. So you guys understand what's going on. No. So, what's 4 divided by 4? 1.
Who said 2?
What's 8 divided by 4? 2. That's pretty easy, isn't it? Yeah. Does that make sense? You look like you're confused. All right, look. That's the exponent. That's the index. You can divide them. So what's 4 divided by 4? So there's 1x up top. What's 8 divided by 4? So there's 2 y's in the bottom. Good?
so you can either divide the outside by the inside or the inside by the outside.
No. It's always inside divided by outside. Okay? All right, so for the 27, I'm going to do this. You could put in your calculator if you want. What's cube root of 27? 3. What's 12 divided by 3? 4. Pretty easy, isn't it? What's the top? Andrew, what's the
Why
bottom?
is it 4?
Y to the 4th. Good.
Why is it 4? C. Why what?
16 by 4 and 4 by 4.
No,
Right.
I'm talking about C. Why is the exponent 4?
12 divided by 3 is 4.
Oh. Okay, shut up.
Any other questions? Okay, listen. I'm looking for a group of
There's no D. There's no D.
4, right? So what's the 4th root of 16? 2. Okay, listen. Pay attention. Some of you are going to get lost if you're not watching. How many times does 4 go into 7? Once. So how many A's come out? 1. But how many A's are left? No.
3.
I took up 4 of them already. So how many are left? 3. So this is A to the 3rd. What's 11 divided by 4? How many times? Which is how many B's? 8 B's, right? So how many are left?
3.
You understand why A to the 3rd and B to the 3rd are left? Liz? Okay, I'll go through it again. 4 goes into 7. One time, right? There's 4 A's, right? So that A comes out, but how many are left underneath? 3 of them. Okay? For the B's, Robbie, pay attention. How many B's is that? How many are left over? Right? So there's 2 sets of 4 B's. That's why it's B squared.
I am listening, Ty.
How many are left? 3.
So that's the beginning part is part of the equation still.
Yeah, this is still part of the answer. The 2 is from the 4 2's. The A is from these 4 A's in the box, rectangle. The B squared is because there's 2 boxes or rectangles of 4 B's. All right? There were 3 A's left over, so that's why it's A cubed. There's 3 B's left over. This is 11 B's, if you count them all, right?
4, 8.
Okay? What's 4 divided by 4? 1. So the C comes out there. Are there any C's left over? No. So that's our answer.
You divide 4 by all those.
Yes. And then whatever the remainder is inside. Is it clicking?
I guess. A little bit. Where's the?
Any other questions on that one? Okay, Caroline.
Oh my
What
God!
am I looking
dropped
for?
the cat.
A group of 3. All right, so let's put them in groups of 3. That's 8 Y's, right? So what comes out front? 2 Y's, but it's not 2Y, it's Y squared, right? What's left? 2 Y's. Am I allowed to leave my answer like that?
No.
No. So I've got 2 Y's in the bottom for a cube root. How many more do I need? 1 more, right? But if I do it to the bottom, I also got to do it to the top, right? Because I'm not allowed to have a radical in the bottom. So I'm trying to get this cube root out of the bottom. So I need 1 more Y to have 3 Y's. Morrison.
Why'd you write Y in this 1/3?
Well, that's sloppy. It should be this. It's Y squared cube root of Y squared. Yeah, I got it sloppy. All right. So this purple and blue together is 3 Y's. So what happens down here? That becomes what? The 3 Y's become a what? Cube root of 3 Y's, or let me say it this way. Cube root of Y cubed is what? 1 Y, right? Y. Okay. So my bottom now is, since this is 1 Y and there's 2 there, how many total Y's in the bottom? 3. Okay. Look, these together is 1 Y, right? Because that's the cube root of Y cubed. That's what ends up happening. Okay? No more radical in the bottom. All right? The top is just that. X times the cube root of Y. I can't do anything else with that. Questions? Ty, you all right?
Yeah.
Good?
Can this get any harder?
Okay, so think about it like this.
Starts off easy. And then just impossible.
So I just kind of split it up so you can see everything going on there. So what's the first answer? 7. What's the rule here? Subtract them, right? Where's the higher exponent? Top or bottom? Top. So what's 4/4 minus 3/4? 1/4. 1/4. In the top, right? There's no other y's. So the y stays in the top. Are we allowed to have negative?
No, you gotta flip it to the top.
Right. Not allowed to have negative exponents. So to make it positive, you move it to the, if it's in the bottom like this, move it to the top. If the z to the -6 was up top, we move it to the bottom. Okay? That's our answer. Haley, ask your question. You're okay. Do you understand I got the 1/4?
Yes.
Okay. There was no other y's here, so
That stayed the same.
I just stayed up there. And since this is negative, we're not allowed to have any negatives when we're done simplifying. No negative exponents. So just move it to the other spot. It's like reciprocal.
So we want to put a 1 on the bottom?
You can put 1 on the bottom if you want. You don't have to.
Wait, what's the homework? We got homework during the weekend, buddy.
Oh.
Can I add those?
Yeah. No. Yes.
Yeah. So what's that equal?
11 Y.
Square root of y, right? Okay. Jared.
Oh my goodness, that's
Okay. So, are they the same radicals?
Yeah.
Not right now, they're not. So let's try to simplify. So, what's my index? How many z's do I have? So there's 3 in there, right? So what can I pull out? Here's 5 z's, right? So I can pull a z out, right?
2 are left over, so it's equal.
So this is cube root of 2 z squared, right?
Dude, where'd you get the 2 from?
Yeah, you were.
The 2 here.
Okay, I didn't see that.
I couldn't do any factor tree for that, right? Pay attention, come on.
We're about to leave. Oh my.
You will leave when I say you can leave. Okay?
I know.
All right.
I didn't know what time it was.
That's because you were actually paying attention today, right?
Yeah.
What can I pull out? 3. All right? Remember, 2 is going to be left underneath, right?
Yeah.
Only have a z squared, right? So what z was out front, so that's still there. 2 from that, z squared, there's not 3 z's there. Are they like now?
Yeah.
Yeah. So what's my answer?
12,
What's 12 minus 3?
9.
Third and then squared.
Simple.
No, it's not simple.
You say third.
I don't know where to get that.
Square root, or what did you say?
Cube root.
Cube root.
Just cube root of 2z squared.
Oh, okay.
All right. Hey, one more thing. Eyes up here. No homework. Good job today. Thanks for listening. See what happens when you pay attention? You actually understand.
Where's my bag? Oh! If I would have forgot my